Today's lesson is topic 7, the solar system up close. All right, so here is a diagram of the solar system. We can see the planets. The sun is here, so we can see our planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, and then Pluto, which is now considered a dwarf planet. So I'm going to pause here. We'll watch this quick video on the solar system. So for looking at the sun first, so everything in the solar system is under the influence of the sun's gravity. It's a huge globe of mostly hydrogen, very hot, so hot that the gas glows. The light from this gas speeds through space to reach and warm Earth. You can see sunspots in some regions of the sun, which are cooler, and therefore they appear to be darker than their surroundings. Something called a solar wind, high energy subatomic particles that stream off the sun and define the boundaries of the solar system. So Earth's magnetic field is what protects us from the harmful effects of the solar wind. The sun's own gravity has compressed its hydrogen so much that the temperature at the center of the sun is about 15 million degrees Celsius, which is high enough for a nuclear reaction called fusion to take place. About 600 tons of hydrogen gets converted into helium per second, and that's how this is how energy is released from the sun. Okay, so next is the moon. We're just going to talk about Earth's moon, even though there are other planets that have moons as well. The moon, it's not a planet. It's called a moon. It's the first place people went to in the solar system. It was July 17th, 1969, when two men landed on the moon. It was Neil Armstrong and Edwin Aldrin. So here we have a couple pictures here, looking at the surface of the moon. So scientists first had to figure out if the surface of the moon was smooth enough for a spacecraft to land on before setting people down on its surface. So that's what we're looking at here. Another diagram here. The former Soviet Union was also interested in the moon. They flew satellites around the far side of the moon and photographed craters that were never seen before by humans. So that's just taking a look at that. It's an Apollo picture of the far side. Okay, so next we are going to start looking at the planets. So we have the inner planets, which are also called terrestrial planets because of their terrestrial or rocky composition. So these ones include Mercury, Venus, Earth, and Mars. Then we have the outer planets, which are also called the Jovian planets. They are similar because of their gaseous composition. So these ones include Jupiter, Saturn, Uranus, and Neptune. So we'll start by looking at Mercury, the closest to the sun. Thin crust, inner solid layer composed of silicate rock. Beneath that, there's a huge iron-rich core, makes up about 80% of the planet's mass. Very thin atmosphere with trace amounts of sodium and phosphorus. You can see the temperature ranges here, as high as 430 degrees Celsius. At nighttime, drops to about minus 180 degrees Celsius. Okay, so it does show that the surface is covered by craters. So relatively smooth, but evidence of past lava flows from volcanic activity. No moons. And here we can see just some other information. For example, rotation period is about 58.6 days, and so on. The next planet then is Venus. So here's a little bit of information about Venus. It has a thick atmosphere. 96% of it is carbon dioxide gas. 3.5% of its nitrogen, and then smaller amounts of other chemicals like sulfuric acid rain. So Venus has the highest average surface temperature of any of the planets because of that carbon dioxide, which is very efficient at trapping solar radiation that falls on the planet's surface. So thin crust, rocky mantle surround Venus's semi-solid iron-nickel core. It has large meteorite craters and extinct volcanoes. Another feature of Venus is that it rotates from east to west rather than from west to east, as do most of the other planets and the sun. Rotation period is about 243 days, no moons. So next is Earth. So Earth, like we know, it's got diverse life forms, large quantities of liquid water. It's the third planet from the sun. Nitrogen dominates the atmosphere at 78%. Oxygen's at about 21%. Thin crust composed of rocks, some of which are 3.9 billion years old. We have a rocky mantle, a molten outer layer, and a solid inner iron nickel core. And then we have the one moon that orbits Earth in about a 1 month period. Okay, so we'll pause here. So the last terrestrial planet we'll look at today is Mars. It's got a reddish orange color because of iron oxides in the surface material. It's got polar ice caps, there's valleys, canyons, volcanoes, there's craters. The fourth planet from the sun. So Mars' distance from the sun reduces the amount of solar energy falling on its surface, so the temperatures can get very low, especially during the nighttime. Atmosphere, it's got nitrogen, about 2.7%, trace amounts of argon, oxygen, and water vapor. There have been probes that have visited Mars and explored the surface of the planet. There's an icy permafrost that's present on the thin crust, and underneath there's a rocky mantle surrounding a solid core. Okay, so next we are looking at the Jovian planets, or the gas giants. So firstly, we have here Jupiter. So Jupiter, it's got a rocky core in the center. It's about twice the size of Earth. The rest of the planet is mainly hydrogen. There's solid hydrogen, there's also liquid hydrogen, and there's also helium present as well. No solid crust is present. There's a gas giant. Hydrogen is the main constituent of the atmosphere, it's about 90%. 10% is helium, and trace amounts of others like methane, ammonia, water vapor, and all of those kind of give that those band-like appearance. What else? We have its mass, rotation period, orbital period, 11.86, I think 17 moons. And one of the moons, called Europa, scientists believe that it may have oceans of liquid water beneath the frozen surface ice. After Jupiter, we have Saturn, noticeable ring system of Saturn. It's a yellowish planet composed of ice-covered rock fragments and dust, colder than Jupiter. Let's see here. It has a structure that's similar to Jupiter, a rock and ice core, solid hydrogen inner mantle, liquid hydrogen outer mantle. The atmosphere is mostly hydrogen, about 94%, and then 6% helium, and then there's traces of those other gases like methane, ammonia, water vapor. Also, it has a rapid rotation, producing those cloud bands which are visible from Earth. And one of the moons of Saturn is Titan, so 18 moons. So we have...
Insert face palm here.
We have Uranus next. So it's got a rocky core, a mantle of ice, ammonia and methane are surrounded by a generally featureless atmosphere. So if you notice, like, there's really no features here. Atmosphere is about 85% hydrogen, 12% helium, and then 3% methane, which will absorb red light, and it makes the planet seem blue. It does have a ring system consisting of about 8 narrow bands. And the other interesting fact about Uranus is that it's tilted. It rotates on an axis that's tilted 90 degrees to the plane of the solar system. So 21 moons, but additional moons continue to be discovered. Okay, so next we have Neptune. Very similar to Uranus, same internal structure, very similar atmosphere, as we can see here. There has been a ring structure discovered in a giant dark spot, and about 8 moons. The moon Triton has the lowest measured temperature in the solar system at minus 235 degrees Celsius. Lastly, we have Pluto. Just remember that Pluto is not considered a planet anymore, I believe, since 2005. It's very far away. Very little information is known about it. What we do know is it spins in the opposite direction to its direction of revolution. It most likely has a large rocky core, an ice mantle, and a water and methane ice crust. It was considered the 9th planet until 2006. Did I put 2005? Yeah, so it should be 2006. Then it was demoted to a dwarf planet. A professor discovered an icy object about the same size as Pluto out beyond its orbit. This object is the dwarf planet called Eris. It turns out that Pluto is just a fraction of the icy object in its realm. So it's now considered a dwarf planet. So 2 videos here on Pluto.